Yeah, it's great to be here. As Tammany said, met her first at the Arkansas Native Plant Society. I believe that was our fall meeting. And yeah, I forgot what happened. I think I had a conflict of some kind last year. Yeah, but glad I was able to make it down. As you mentioned, this is what I consider my ancestral homeland. My dad's side is from Lake Charles. My mom is from the Mississippi Delta. But my dad's parents, grew up on the Cajun Prairie. My pawpaw's from Mamou. My grandmother's from Brazil. I grew up in Little Rock. I now live in the northwest corner of Arkansas up in the Ozarks, Fayetteville. I'm not going to call the hogs here, don't worry. I know better than that. My dad's a huge LSU fan, so he raised me to know who to root for. But anyway, really glad to be here. Appreciate it. I think there's some people that I've been communicating with electronically that I would like to chat with sometime today. But this is, like Tammany mentioned, I work for an engineering firm. I work with engineers. I'm not an engineer. My background is natural resources, environmental science. But a lot of this program, I give it normally to engineers. And they think in terms of function and how do things work and how is it useful, So, keeping that in mind, a lot of this is going to be framed around like, how is it useful? But I know the audience I'm speaking to, I don't have to convince you of the value of native plants. They have their own intrinsic value, right? Just outside of their usefulness to humans. But I didn't have time to completely redo this presentation. So you're going to hear me talk a lot in terms of how is it useful to people, right? Just keep that in mind. That's not necessarily aligned with my personal views. But what I do find is we do get a lot of our clients, even in the private sector, that are very interested in using native plants because when they're thinking of economics and budget and money, they find that they are definitely much more budget friendly than using a lot of non-native species. They're a lot less maintenance. There's a great golf course up in northwest Arkansas in Fort Smith that found that they were able to really cut down on their expenses by converting a lot of that golf course back to native prairie because it was once built on mastered prairie. And so just, to me, that golf course is just an inspiration for others in other areas. Renewable energy projects like solar arrays. We do a lot of developing vegetation soil management plans for pollinator plantings under these arrays. And the solar companies are realizing that having vegetation under their arrays makes them more efficient, helps keep the undersides cooler, so they're able to produce more energy, but also they're a lot less maintenance and cost when it comes to maintaining these than just having your typical gravel or whatnot. So it's good to see that at least some of these agricultural areas, if they're being converted to something like renewable energy, at least a lot of these solar companies are interested in putting pollinator habitat back in there. It's not going to provide the same ecosystem services that it would if it was natural native prairie, but it's at least, in my opinion, better than something where a lot of herbicide and pesticides and fertilizers are going down into. But, all right, so let's kick this off. Let's see, how do I advance the slides?
I'm not sure that your mic is even working.
It didn't seem like it was. Okay, so y'all can hear me. I can also just talk loud. I don't want to scream into here, but I could scream into the air.
I think that's fine.
Okay, I'll continue using the mic. But if anybody cannot hear me, especially in the back, please raise your hand and we can figure out another solution here. Well, the arrow keys don't seem to be working, but I think it wasn't working either. I just need to do that?
You can do it back there.
Okay, maybe I just needed to click it once.
We've got this here too.
Right, we tried it earlier. It was having some issues.
It was?
Yeah, the pointer works.
So does it click?
It's working now. I'll use it until it stops
Use
working.
these things.
Right, yeah.
Okay.
I'll use it until it stops working. So how about that? All right, so native plants with a purpose. Again, I'm giving this for engineers at various conferences, whatnot. So they got to think, well, how can I use this? They're thinking in stream bank stabilization, rights of way, erosion control. But some of them, because of permitting regulations, need to be considering environmental quality. And a lot of clients, too, are really looking at trying to improve their getting either whether that be LEED certifications, Envision sustainability ratings. These are different certification programs, and these really do help them when it comes to the public eye. But specifically, I'm going to talk about phytoremediation. So I'm going to start basic. Got to take out the whole section of the presentation where I get to explain what a native plant is, because I figured y'all know that. Why native plants are important ecologically, I figure y'all know that. So we're going to jump right to the heart of the matter here. What is phytoremediation, just in case anyone here has never heard that term before, because that is a $20 word, I'll be honest. These are plant-based methods of remediating or containing environmental contaminants in air, water, soil. So we see this used in some certain situations, but not others. Now, there's research done on how it can be used for large-scale brownfield remediation sites. The issue with using it when there's a lot of contamination is the length of time that takes. Unfortunately, when you have heavy metal contaminated sites, they're wanting to get it done quickly so they can reuse that site. And so excavating and hauling the soil and doing some sort of cleansing or washing is typically what they do. To use plants to do that, it's going to take years or decades to get those heavy metals out of that soil. But there are still practical applications for using native plants in phytoremediation, especially when it comes to where there's low to moderate levels of contamination, things like stormwater. So, we all know that as our society has grown and developed and we have all these impervious surfaces on the landscape, parking lots, roads, buildings, you go out to like a Walmart parking lot on a day when it's not very many people out there, and you're going to see all these stains on the asphalt or concrete, right? These are automobiles dripping, fluids, petroleum, all automobile fluids, and all you need is a heavy rain to come through, dislodge some of that, especially if it was freshly deposited there, and to carry that into the nearest storm drain or creek. A lot of places, stormwater isn't treated, and a lot of people don't realize that when stormwater goes into a drain, it's not improved in any way. Oftentimes, it goes straight into nature. And so that can wreak havoc on aquatic habitats depending on what it is that's going into the stream. So think about neighborhoods. People are having their yards sprayed with fungicides or pesticides, having their houses sprayed for termites or whatnot, and you get a lot of these pesticides. If it's applied and there's a heavy rain, a lot of these are going to end up in the aquatic ecosystem where they are really harmful to the ecosystem. And so this has an issue with stormwater pollution, poses a risk to our drinking water, depending on what's in there. Some stuff does have a natural ability to break down over time due to different things, but it can be, like I mentioned, harmful to aquatic ecosystems. So how can we improve stormwater quality? Well, some plant species can break down and or take up these contaminants. And they do these through a few different methods, and I'll go into this a little bit, and how we can make use of what we're hearing more and more about are nature-based solutions. And that's something where I really focus on in my work is helping municipalities, regional planning commissions utilize nature-based solutions to improve environmental quality. So, as we know, a lot of our perennial, especially the prairie species, have these very deep root systems. And so, one thing, using these species is going to help a deeper infiltration of that stormwater into the soil. And that soil, because of the soil microorganisms and biota, fungi, are really good at breaking down in contaminants. So some of these contaminants are food sources for certain microorganisms. Even petroleum, as long as the amount of contaminant isn't so much that it's going to prevent the plants from growing there. Like, I don't know that this could be done to clean up the BP oil spill. Whenever there's so much contamination, it's going to have too much of an impact on the living organisms, and so that you have to look at other forms or other ways to remove those contaminants. But when there's low levels, like you would see in stormwater, this is much more effective. So trying to get the stormwater, instead of running off like it would if there's an impervious surface, these roots travel down. When a plant dies, that root leaves a cavity. That helps the water get down into the soil profile much deeper. There's also a little bit of a gap between the root and the soil. That's another channel for the living plants that allows that stormwater to drain much deeper. And so we have a process we call phytodegradation. Now, this is where these pollutants are degraded outside of the plant and then incorporated into the plant tissue and used as nutrients. And so it's degraded outside the plant, whether that be by microorganisms that are already there, other parts of the soil ecosystem, What the plant's function in that is the root exudates. Roots, are exuding all sorts of stuff that helps stimulate a lot of that microbial activity. And so, but through phytodegradation, these things are already broken up by the soil processes, but then the plant is able to take up the components that might be not harmful to that plant and incorporate it into its tissue. So, here we go. Okay, that's what's going on. Yeah, got a little graphic going on there. All right. All right, so yeah, it's broken up, taken up by the plant. Then there is phytostimulation. I mentioned those root exudates. That's where the presence of those roots is stimulating the soil, helping break down these contaminants through that microbial activity in that rhizosphere. What is the rhizosphere? That's the area around the plant root or rootlet. Okay. So has this got a little animation? Yeah, okay. Sorry, the people at my work made all this. So yeah, so these microbes going, breaking it down, and then it's broken down. All right, and then yeah, and from there it can be incorporated into the plant. So now all plants have this ability to create phytostimulation. Some are just better at doing it than others. So literature shows that all plants can facilitate the breakdown of low levels of petroleum, whether that be the amount you normally see in stormwater. But when you have a more fibrous root system, you're going to have a greater volume of the soil underneath that plant that is taken up by the rhizosphere. Versus a taproot system, you're still going to have some of that phytostimulation going on, but you're talking about a small area, close to the roots. So when you have less surface area associated with root systems, you're going to have less phytostimulation. So a fibrous root system is going to provide much better phytostimulation. All right, so what are some examples of species? And I tried to make sure each of these are going to be native to here, to Louisiana. So big blue stem, and there's been research out there. I could send you articles and papers and whatnot. I didn't cite them because there's just a ton of them that show that big blue stem is good at breaking down petroleum products as well as several different kinds of pesticides, such as atrazine, which is widely used herbicide used primarily in agriculture, and can be applied before and after planting to control broadleaf or grassy species, or insecticides that are used to control foliage like chlorpyrifos. I don't even know if I'm pronouncing these herbicide names correctly. I read these things like the Latin names of plants. I read them, and then when I get together with people, I realize I've been pronouncing them differently in my head than everyone else does. Pendimethalin, a selective herbicide used to control broadleaf weeds, used in crop and non-crop areas and on residential lawns and ornamentals, as well as some others. I won't bore you with all the pesticide details today. All right, switchgrass. All right, again, petroleum products and at least two of those pesticides. It's been demonstrated in research conditions to be effective at remediating. Indian grass or Gastrum nutans. I could probably use the Latin with this group. Again, same as the switchgrass. Little blue stem, been shown to be effective with petroleum products, low levels, of course. Eastern gamma grass, we add perchloroethylene, which is a chlorinated solvent. So I believe that's involved somehow in the dry cleaning process. So you get PCE is the acronym for that, TCE, tetrachloroethylene. No. Nodding bulrush, one of these wetland species, plenty of those around here. You aren't short on wetlands. But petroleum products, Scirpus pendulus, got that pendulum-looking fruiting body. Green bulrush, and arrowhead, Sagittaria latifolia. Let's get into some woody species. Bald cypress. Y'all have bald cypress down here? I think so. A few, right? They're rare, right? Yeah, one of your track species. But also, effective with fertilizers. When you have excess nutrients and some of the heavy metals like lead, cadmium, or zinc. River birch. Again, you got TCE, or tetrachloroethylene, one of those $20 words. Vinyl chloride, and pesticides like bentazone. Oh, I'm getting ahead of here. Sorry. I need to switch this to where I'm looking at the right slide. This has got one where it's got me. Okay. There we go. Okay. I apologize if I was throwing anybody off. So river birch. Bur oak. Quercus macrocarpa. It's got that big acorn. Black willow. Again, petroleum products, tetrachloroethylene, pesticide, bentazone. Sandbar willow. We have a lot of these up in my part of the country on the Buffalo River. Anybody ever been up to the Ozarks? Oh, all right, yeah. See, I like to come down here for vacations, and see your part of the world. We get a lot of people coming from South Louisiana up to where we are. I'll tell you, it is very different in weather right now. In the
summer too.
Oh yeah. It's definitely much more humid than it is right now up there, and it is a lot warmer. The car thermometer said 70 degrees when I was driving over, and I think we are at. I think we're not getting above freezing where I live today, or maybe it's tomorrow. But
Supposed to get to 80 here.
oh wow, man. Well, I'm at the part of the winter where I'm ready for spring. But I don't mind the snow the first time or two. But whenever we have a whole week where it never gets above freezing, I'm done.
You can come back anytime.
Yeah.
Yeah, right. Be happy to. So how can we use these? This is where you have what we call green infrastructure. So rain gardens, bioswales, vegetated swales. I got some on here that aren't necessarily used for natives, like, I guess you could have grass swales with native vegetation. Green roofs, this is going to be a little tricky. There's a company up in my part of the country called Ozark Green Roofs that is looking at how to have native plants in green roofs. So there's some different considerations with the root systems and how it drains, and engineered soils that tend to have be using those. So if anybody has experience with successfully establishing native plants on a green roof, would love to hear what you found has worked. But also nutrient pollution. I mentioned nutrient pollution. This is where we can also have uses in agriculture, whether that be for planting along agricultural fields or along creeks or streams in agricultural areas. Excess nutrients, when they're leaving a field, can create issues with eutrophication. That's another one of those $20 words. I'm not going to quiz anybody here afterwards, but eutrophication is when you have so many excess nutrients that it causes these algal blooms. These algae then they consume all those nutrients and they die because they run out of food. And then when they break down, the microbes that are consuming those consume all the oxygen, dissolved oxygen in the water, and then you get these hypoxic zones. I'm sure y'all are well aware, living down where you are, about what the Gulf hypoxia. Gulf. I'm not going to say the name of the Gulf because it's kind of controversial right now. I don't know what audience I'm speaking to there, but I won't get into it. But anyway, how much of the continental United States is drained down here to the Gulf of the Gulf? Just call it the Gulf. Yeah. Okay. And so, having more of these plants on the landscape in these agricultural areas could be very beneficial. So anyway, sources also include sediment from erosion. This is where I'm speaking to engineers, helping them understand the importance of erosion control, especially with our contractors. I speak to a lot of landscape contractors and different conferences there as well. Leaves and grass clippings. A lot of people don't really realize that whenever you mow your lawn or have all the grass clippings, some people just blow it into the street. And so when you have a rain that gets washed into a creek, that stuff does contribute nutrients to the local waterways. And so when you have enough of that, that could create an issue. Animal and human waste. So you have pet waste. That's not an uncommon thing. In Fayetteville, there's one of the streams that is impaired for E. coli because of just our university that has studied it thinks that the source for that is just pet waste in all the residential lawns. So it does happen. And there's a lot of trails and whatnot we have in town, and people walk their dogs on there. And so there's a big effort to educate people on how to, the importance of picking up their pet's waste. All right, so if we want to use native species for optimal nutrient removal from stormwater, again, deeply rooted species are going to provide the optimal benefit. Fast growth rates, especially when you're talking about herbaceous species or woody species, these are going to be able to pull up more nutrients in a shorter amount of time. And the plants that produce a high amount of biomass, so things like switchgrass, big blue stem. Switchgrass puts out a lot of above ground biomass in a single year. It's got very deep root systems. I mean, this is perfect. So if you're wondering about some woody tree species that have some of these characteristics, eastern cottonwood, red maple, bald cypress, box elder, black willow. I'm seeing more of these used in landscaping, which has been very encouraging. And some of the same herbaceous species, I mentioned the big four as we call them, the Indian grass, big blue stem, little blue stem, switchgrass, but also side oats, grama. You want to throw in a cool season grass, Canada wild rye, then the eastern gamma grass, another good one. I used to work for a stream restoration company where we would go harvest eastern gamma grass from the university because there was an old professor that studied phytoremediation with eastern gamma grass, used to grow them. And man, have you ever tried to dig up eastern gamma grass to use at a restoration site? It was local ecotype is the reason we wanted it. And he had retired, and the person that managed a farm at the university, didn't need it. We would had to dig a small trench around one side, put a chain in that, hook the other chain to a truck, and then my coworker would get in that truck and gas it. And that chain would cut up under the underside. We'd take it, then I had to go chop it up with a shovel, not realize at the time it would have been a lot easier with a reciprocating saw, but I got a lot of upper body workout when I worked there, trying to chop up the best I can eastern gamma grass with a shovel to get the different root rhizomes to be able to plant in different locations so that they can then take over. But anyway, it's a fun story. Applications, riparian buffers, edges of lakes and ponds, and constructed wetlands. All right, what about air quality? Talked about water quality, stormwater quality. Let's talk a little bit about air quality and particulates, especially if you live anywhere near like an industrial part of town, anywhere that's got a lot of soot, smoke, dust. Dirt roads is another place where particulate matter enters the atmosphere. Coal-powered power plants, is that how you say that? Coal-powered plants, electric plants? Anyway, other sources, automobile emissions, construction sites. So there's different particulate sizes, different classification. They have PM10, PM2.5. And just for reference, you have a grain of sand is around PM90, and that number relates to the number of microns. That's the measure of units. So PM10 is about 10 microns in diameter. So that's where you got dust, mold, and pollen. These are these green pieces here, next to a strand of hair, which is about 60 microns. And then PM2.5, much smaller. These are combustion particles, organic compounds, metals. Heavy metals can bond and attach themselves to particulate matter. That's the other thing. So it's not just sediment or other carbon or whatnot. The issue with PM2.5 especially is that it could get lodged deeply into your lung tissue and to where coughing and your natural processes of removing that aren't able to expel it. And so you get all kinds of problems with irritation of the throat, reduced lung function, cardiac diseases, cancers, that sort of thing. So controlling particulate matter, even if you can't see it, if it's enough of it in the air, a lot of times it's so small it's not visible. A lot of times you can see it's like a haze if you've got a nice view where you can see really far and you can see a lot of that and how the light shines through it, then it kind of becomes a lot more obvious that there is smog or something that you're breathing in every day. So there's a process called phytoaccumulation. This is where you take airborne particles, like I mentioned, they can also, this isn't the process, but setting it up, airborne particles can also carry a wide range of other contaminants. I mentioned the heavy metals, but then there's also polycyclic aromatic hydrocarbons. That's another $20 word. persistent organic pollutants. But phytoaccumulation refers to the process where these particulates deposit onto the surfaces of leaves, which can help decrease the concentration in the atmosphere. Now, some of those are going to be absorbed by the plant. Most will fall off the plant and be deposited onto the ground. So it's not a way of removing it or making it less contaminated in the environment. It's just a way of removing it from the air and putting it somewhere else where it might be less toxic. So there are some contaminants where the level of toxicity in the soil is an issue, but when the plants are able to utilize phytodegradation, phytostimulation, and they take it up, and then if it's expired through the leaf surfaces into the atmosphere, that same concentration in the air is much, much less toxic. So the medium is important when you're talking about its toxicity to the ecosystem or to human health. So what characteristics of plant species are going to be optimal for phytoaccumulation? Well, the best are going to be needle-leaved species. So these have a high surface area associated with them. They also have these little spaces between the needles where the airflow is going to slow down, which facilitates that deposition much better. So these are much better collecting those ultrafine PM 2.5 particles, more so than broadleaf species. But it's not to say broadleaf species are completely useless. You know, all plants can do this. Some are going to do it better than others, right? So broadleaf species, if you're selecting species with broadleaves, choose species with waxy leaf coatings, leaf hairs, those fuzzy leaf species, or species with a greater leaf area index. These are going to be much better than broadleaf species that lack those characteristics. So again, there's more than one pine, but I just picked one. This also happens to be a big native pine in Arkansas. So less work for me to adapt this presentation, as well as bald cypress, which of course, as we know, is deciduous. So any particulates that might still remain on those leaves would definitely fall down at the end of the growing season. Threw in some waxy leaf species like black gum, black cherry, tulip poplar. And then, you know, honey locust and black locust. And I've seen honey locust used as street trees. This is in Chicago, where you have a lot more traffic, a lot more particulate matter in the air in these high urban areas. I have not had a chance to visit New York City, but places like New York City where you get in Manhattan, where you get these street canyons, that's where air doesn't have a good opportunity to leave these street canyons. And so that's where ground level ozone becomes a big issue in these areas. Also, back when we had leaded gasoline, think about how much that particulate had lead attached to it, and all the people walking down the road getting lead exposure. Let's talk a little bit about NOx gases. Nitrogen oxides, these are also created by the combustion of fossil fuels. Overexposure can also cause irritation to the respiratory airways and to the mucosa of the eyes and the nose. So especially those already struggling with diseases such as COPD or asthma are going to be especially susceptible to these adverse effects. I had a friend that went over to teach English in China, where the air quality there was much, much worse. She had never had issues with asthma before in her life until she visited there. And when she came back, it took a while for her body to readjust. But yeah, she had more environmental triggered asthma from being in a place with much, much worse air quality. Black locust. Now, this is one I always caution people, because in some places they consider this a little more of a noxious species, but not always. This is a native species. But there was a study where they looked at 70 different street tree species to see which ones have a high assimilation of nitrous oxide and which ones have a high resistance to tissue damage from nitrous oxide. Now, the thing about nitrous oxide, yeah, when you breathe it in, it causes damage to your lung tissue, but it can also cause damage to plant tissues as well. But of those 70 tree species that are used commonly in street trees, they found 4 that had both those characteristics: high assimilation of nitrous oxide through its leaves, and a high resistance to tissue damage from nitrous oxide. Of those 4, 1 was native to North America, and that was black locust. So I'm of the type where I like black locust. I don't have an issue when I see it. I think a lot of times people think of something as being noxious in certain conditions, green ash, native species, but sometimes in wetlands it does take over, and people don't like green ash if they're trying to manage a wetland. Same with like cattails. Personally, I believe in just kind of letting it all take care of itself, but as humans with society, that's not how a lot of us think. All right, air pollutants dispersed primarily by wind. Duh, right? Particulate matters originating from roadways often travel up to 240 feet from their source. So what can we do about that? Well, if we have, got another. So keep this fact in mind. The other thing is another study was conducted, Yang et al. Found that the size of the plants being used matter. This was a study conducted with green roof vegetation in the city of Chicago, and found that larger plants and species with a greater leaf surface area were better at reducing airborne contaminants than species that lacked those. And so they looked at everything from nitrous oxide to sulfates to PM10, ozone, that's that O3, and that was the conclusion of that study. So keeping in mind that these things can travel 240 feet from their source, that they're from automobile emissions. If we have a high traffic roadway, interstate, maybe there's a neighborhood near there, that's where maybe when I'm talking to urban planners, landscapers, considering using some of these species, especially if you can have some sort of vegetated buffer in there to help reduce the amount of particulates that are getting into that neighborhood. Or maybe there's an industrial part of town. Down here you have a lot of oil refineries. I haven't looked into the process there to know what the particulate matter, but I'm sure there is some. A lot of people forget how bad air quality was before the Clean Air Act. A lot of people weren't even alive to remember, none of us really, how bad water quality was before the Clean Water Act. Who knew that rivers used to catch on fire? It sounds silly, but our rivers were so polluted, they used to be flammable. And there was a lot of loss of life and property and whatnot, putting out these fires. I mean, how do you put out a fire of a river without pumping water from that river to put out the fire? I mean, you got to haul that water in somewhere, I'm sure. But if you look up the Cuyahoga River Fire, look up the river fires of the late 1800s and early 20th century, this is what spurred the initial legislation that later became the Clean Water Act. The initial legislation was formed in the 1940s. And then it didn't have enough teeth on it, and so that's why the Nixon administration in, I believe, the 1970s signed the Clean Water Act. And since then, rivers don't catch on fire anymore. I mean, I think they stopped catching on fire earlier than that, but water quality has since improved significantly. All right, what about carbon sequestration? Another thing that we get hired to do are these climate action plans. I just finished writing the climate action plan, turned it in Thursday before I left to come down here for the Northwest Arkansas region, and wrote the Fayetteville, Arkansas Climate Action Plan, which utilizes a lot of nature-based solutions for climate resilience and also for mitigation of climate change by enhancing carbon sequestration into the landscape. So there's different mechanisms through which carbon can be sequestered into the land. Wetlands are great at storing carbon. These soils are very anoxic, another $20 word. They have little to no oxygen. And so the microbes that use that anaerobic process for metabolism operate or metabolize much more slowly. And so you end up with a buildup of organic matter at a quicker rate than it's being broken down. So that's why wetland soils are very dark and rich in organic matter. That's why they were drained historically to be used for agriculture. And that's why we don't have very many of the original wetlands that were here. They also provide other functions from flood control to water purification. That's a whole nother talk. Or you can just use the species I've listed if you get to do a constructive wetland. But they're called the kidneys of the landscape. But when you have plants that are through photosynthesis taking in carbon dioxide, I'm sure I don't have to explain any to y'all how photosynthesis works. You know, exhales oxygen, right? And that carbon stays in the plant as woody matter. When these plants die, they get deposited to the bottom of the wetland, and that organic matter builds up. Then there's prairies with these deep root systems. These deep root systems, these plants are growing, they're sequestering carbon, putting it down into this root growth that extending further and further down into the soil profile. This plant eventually dies, and that root system will decompose, but it's not getting exposed to enough oxygen for it to off-gas back into the atmosphere. Also, those root exudates that I mentioned earlier that they're exuding or another way that carbon passes from the plant into the soil ecosystem. And so when it's there, especially deeper in the soil where it's not going to be tilled, it is able to remain there and be sequestered. And then forests, primarily an above ground growth. As a tree or woody species is growing, it's taking that carbon, incorporating it to its woody biomass. The thing about forest, they are able to sequester carbon much quicker, and they're better as a short-term solution. But there's a limit to how much carbon above ground a forest can store, because there's a limit to how much trees can grow. Whereas prairies and wetlands, they found a significantly greater amount of carbon can be stored in the soils of these ecosystems. So these are much better for long-term carbon sequestration solutions. Prairies and wetlands won't be able to get us to net zero by 2050, which is a lot of goals that we're seeing around the country and the world. Forests are going to be much better, not so much with planting trees, but with protecting existing forests, preventing the loss of carbon in those. So, I mean, planting new forests is going to be helpful too. But if you're looking at meeting goals in that short term of 25, 30 years, you got to be strategic. All right, so what are the characteristics that are going to be optimal for above ground carbon sequestration? Well, fast growing trees are going to be able to store more carbon during their first decades. Long-lived species are going to be able to store that for much longer before they're releasing it through decomposition. That's the thing about these trees is, when they die, they're in this more oxygenated environment. So a lot of that, when it decomposes, the carbon is going to go back into the atmosphere. Trees with large leaves and wide crowns that are able to maximize photosynthesis have also been found to optimize carbon sequestration. So, formatting is a little off on here, but some other examples: bald cypress, black gum, tulip poplar. These are all long-lived species. Pine, shortleaf pine, white oak, chestnut oak, northern red oak. All right, so what about characteristics for optimal below ground carbon sequestration and storage? So this is where we need species with deep root systems. Again, we're thinking prairies, right? Perennial prairie species. These deeper root systems, as I mentioned, can put carbon deeper into the soil profile than shorter root systems from like annuals can. More fibrous root systems, as I mentioned earlier, can sequester a great amount of carbon into the soil than species with taproot systems. Again, a lot of that is that volume of soil that's taken up by the rhizosphere and the exudates that are coming off out of those root systems. And then you have a greater volume of soil that is going to, when that plant dies and decomposes, that carbon is going to be left behind in. Long-lived perennial species are also going to be able to store carbon for longer and sequester more carbon over time than short-lived species. All right, so again, we got a lot of the big four: the little blue stem, Indian grass, switchgrass, big blue stem, along with a few others in here: pink muley grass, prairie dropseed, river oats. Applications: well, these woody species, potentially as urban street trees. When we're talking about nature-based solutions, this is one of the things we can recommend. However, I mean, it's going to not have a huge impact, I'll be honest. Really, when you're looking at impact, you really need a wide area of forest planting that's going to have your greatest impact. But every little bit can help, is the way I look at it. So having species, as you saw these lists that I'm providing, some of them have more than one function, right? And so selecting species like bald cypress, which does just fine in an upland environment, if it's planted there, if it's already germinated and potted, I see this used a lot as a street tree in parking lots up where I live. Naturally, it likes to grow in wet areas because I think you can replicate a lot of that germination process that it requires that wetness in a greenhouse, and once it's growing, then it can be transplanted. Municipal corporate landscaping used as in climate action plans and conservation plans. So another part of the climate action plans that when we recommend nature-based solutions is for cities and their parks to develop a conservation plan for the park that includes wildlife habitat, native species in the landscaping, and carbon sequestration. All right, and so that is my talk. I'm glad I didn't go over because I can definitely get to talking for a long time. But it looks like I got a little time left. But yeah, I'll take some questions, but I do want to say, feel free to email me if you have any questions. If you don't get a chance today, if you just want to reach out, or if you want some references or articles, or just want to connect, maybe you're working on a similar sort of project and kind of want some ideas, happy to connect with like-minded people on how we can use native plants to improve environmental quality. But